We are now graphing trig functions. Okay? So, y'all have to memorize, Ryan, what sine x. The first one is the basic one, the standard graph for sine x. The second one you're going to have to make some changes to. So the first one for sine x, we learned yesterday, Ryan, that it starts, it goes up to 1, back to 0, down to 1. And that is one cycle, or as we say, that's one period. Okay? So y'all have to know that one. You have to have that one memorized. Go ahead and graph that. I want y'all to graph the first graph in your pencil. I want you to graph your final graph in a color. All right, so one thing, guys. Question, Wes.
I said this location change up and down.
All right, one thing I see that I forgot to write on y'all's worksheet, well, on the first three anyway. I didn't write a place for amplitude, period, phase shift, and location change. If y'all would just write that right at the top right here would be fine.
Do these have to touch certain places?
Yes, I mean that has to go up to 1.
I can't do that.
Yeah, I've never seen a graph in 25 years like yours yesterday. That was the first. All right, I'm going to show you right now. The next thing I need y'all to do, Gracie, I need y'all to write down amplitude, period, phase shift, and location change, and then I'll show y'all how to make your new graph. Y'all can just write it down right at the top right there. That'll be fine. Any place you can fit it in.
Well, are we going to have to move it up because it's no longer in that space?
Are we going to have to move this one up? Yes, because it's got an amplitude of 3, so I know right away we're going to have to move. Probably just fit it right here, be good. Just write it real small. All right, Ryan, you ready? All right, Ryan, what's my amplitude going to be on my new graph? 3, good. All right, Ryan, do you remember how to find period? This is what we've been doing for 3 or 4 days. Remember, Ryan, the formula is 2 pi over k. So, k is the number in front of x. 2 pi over 1 is 2 pi. Good. Is there a phase shift? How do we know? Good. Is there a location change? Up to. All right, so that's what y'all should have written down for your answers. Ryan, you good? All right, now, Ryan, one thing I need to show you is, just watch me here, Ryan. This line goes on forever, okay? But I'm only making you guys write it from 0 to 2 pi. But it runs on forever in both directions. From where it starts, it runs a cycle, Ryan. When it gets back to where it starts, that's called one period, or one cycle. It's ran its course for one cycle. Does that make sense? All right, so what I want to show you is, period on our new graph is 2 pi. Well, look, it was already 2 pi, so we don't have to do anything to that, guys. I meant to mark it out. That's not going to be a change. The only ones we got to change, Ryan, are these two. And when you have more than one change, I want y'all to start at the back, remember, and work your way to the front. All right, so let's do this one first. What do I do with this graph if my location changes up to? Hey, Ryan, all you do is draw you a new one. You see where this dot's at 0? You move everything up 2. That's all you do. So draw me a new graph that looks just like the first one. You just move it up 2.
Do we do that in color?
So 1, 2. No, because that's not your final graph. There. I moved everything up 2. All right, Mitchell, hurry up and finish that and let's put that up for a minute. I'll be done in a minute. Ma'am?
Maybe if I had the lines like you did.
Probably so. All right, last. Okay, so we've done that. We moved everything up 2. Ryan, last is the amplitude. Now watch me on the amplitude. All right, one thing I forgot to say. Taylor, when you move everything up 2, give me a dotted line up 2 because that's your new x-axis. You know, it was right here, Ryan. I moved everything up 2, so give me a dotted line up there.
You can put a dotted line for the answer?
You can go ahead and put that in your answer.
Or do you want us just to have that as the...
I mean, if you don't write the dotted line, I'm not going to mark it wrong, but it helps me. Because now my amplitude is 3, Ryan, so watch. You ready? On my last graph that I drew, you see the 3 dots on the x-axis, Ryan? Those never move. You see this dot that's up 1? What you do is times it by 3, so now you're going to go up 3. 1, 2, 3. Now it's up there. All right, Ryan, you see the dot that went down 1. Since your amplitude's 3, you're going to times it by 3, and now you go down 3. 1, 2, 3. That's your final graph right there. Make you smarter? I doubt that. Maybe so, though. Maybe you found something there. All right. Anybody got a question on that? All right. Now, we only got 5 of them on this sheet. Y'all ready for number 2?
Okay.
Ryan, you got a question? You okay? All right. Number 2. I'm going to erase mine. You guys can go ahead and draw the basic graph. If you were here yesterday, you should be able to draw the basic graph. Number 2 says y equals cosine x. All right. What did we say the graph of cosine x looks like?
Handlebars?
Looks like handlebars on a bicycle. So it's here, it's here, it's here. All right, Ryan, notice. It kind of looks like a V, right? But I want you to draw it where it looks like handlebars on a bike. So, Gracie, you're going to have to memorize on number 1 what sine looks like, and you're going to have to memorize what cosine looks like, and that's where you start off. And now those are the only ones that we're doing. We're not doing tangent. We're not doing cotangent. Y'all can do that in college. We're only doing sine and cosine. Now, I showed this yesterday. Ryan, let me show you something. You don't have to write this. If you look at your graph for sine, it looks like that. That was number 1, right? Well, Ryan, look, if you take that and slide it down, I mean, it really matches up with the other one. So they're really the same. It's just one's been slid over. Okay? All right. So y'all got the basic graph for number 2. So let's see what we got to change. I think we only got to change one thing in this one. Y equals cosine x plus 3 pi over 2. All right. Ryan, let's go again. What's the amplitude on this one, Ryan? See how well you know this stuff. 1. Very good. What's the period?
Period is 2.
Very good. 2 pi. Now, how do I know this one's got a phase shift? All right. Do you remember how to do phase shift?
No. It is the, isn't it negative C over K?
Yes. Do you remember the shortcut, Sal? You flip the sign on this one, so that's negative 3 pi over 2, and you divide it by what number's in front of x, which is 1. So that's just going to be negative 3 pi over 2. All right, and there's not a location change. All right, so guys, there is only one thing we got to change on this one. Levi, I just got to do my phase shift, because look, period 2 pi, it was already 2 pi. We don't have to change anything about that. The amplitude says 1. The amplitude's already 1. They're already going up 1 there and down 1. We don't have to change that. The only thing we got to change is what? Phase shift. Now remember, if it's a shift counter, it either moves it forward or slides it backwards.
Do the same thing on the other side.
So all you have to do on this one, Ryan, it says my phase shift is negative 3 pi over 2. Find where that is on your graph. Right there, negative 3 pi over 2. All you have to do, take your graph and slide it back to negative 3 pi over 2. That's it. So you're going to draw a new one. I'll draw it. Let me get my creative pen. I like these. Let's go with the smiley faces. So I go back and I start it here. So you're drawing the same exact shape.
Where'd you start it?
It says started at negative 3 pi over 2. So I just moved it back and that's where you started at. All right, question. All right, Blake, it's like taking this graph and just dragging it back and start it wherever they tell you to start it. And they said started at negative 3 pi over 2. That's all I did. Okay, now look, that was an easy one. We only had one change on that. All right, let's go to number 3. While I'm setting up number 3, you guys need to write down amplitude, period, phase shift, and location change. This will be the last time y'all have to write it down. So y'all can do that while I'm setting up number 3. Weston, you ready? I need you to give me my 4 new answers on number 4. What's the amplitude going to be?
2.
Period.
2 pi.
Okay, Michaela, this one didn't change, so we don't have to worry about the period. All right, go ahead, Weston. Phase shift.
Negative pi.
Very good. And location change.
Up 1.
All right, so this one's got 3 changes, guys. So we're going to start in the back and do them one by one. Does everybody understand that this one's not changing? Because it was originally, whoops, I didn't draw my first one, did I?
That's what I'm waiting on.
My first graph, Michaela's cosine, that's when y'all start up here, and it looks like handlebars on a bike.
So it only goes down to 1.
So after another day, we should have that memorized, what the original graphs look like for sine and cosine. If nothing else, y'all could have looked back and got it off number 2.
I have a question.
All right.
For since it's got change in amplitude and location change, would that mean instead of it starting at 1 and start at 2, or would it?
Well, you're mixing me up. Just let me show them 1 step at a time.
Right.
Some people who are smarter than me, like Clifton, tries to do more steps in one
Do
move.
them all at one time.
Yeah, and that's fine. If you want to do that, that's fine. I have trouble doing that. I'm going to go one at a time. All right, so location change. What do we have to do, guys, for up 1? Move everything up 1. It's like grabbing it and sliding it up 1. That's what it's like. All right, so you guys draw me a new one. I'm going to move everything up 1. There, 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 there. All right, now, what is very important when y'all go up 1? Blake, Levi, Mitchell, make sure y'all listen. I want y'all to give me a dotted line up 1 and 2. That's going to help us know that that's my new x-axis. So when you go up or down, draw me a new x-axis. All right, any question about the first step? All right, we got that step done. Clifton, explain to me about a phase shift of negative pi.
We'd move it back to the beginning
Yeah.
of negative pi.
Right, find where negative pi is. It's right here. You're just going to take this, and you're just going to slide it back and start it at negative. Whoops, I missed it. Start it at negative pi. That's all you're going to do. Just slide everything back 2 spaces. All right, so I'm going to draw one just like y'all are drawing one. There. I slid it back. So my last one I've done is the blue one. I've got one more change to make. You think it would help if y'all had a better graph?
Yeah.
I'll work on that for the test.
Little lines like you.
I think it would. It makes it neater for sure. All right?
The green would definitely help.
All right, so Levi, can you do the amplitude, the last step?
There you go.
All right, now remember,
Keep 3 points.
there you go. Keep the ones that are on the x-axis. You never move those. And now instead of going up 1, it says go up 2, and where it went down 1, go down 2. There you go. All right, we got one more.